to the next set of slides. Make this a little smaller. So this is Verilog 2. So the first thing we're going to talk about is finite state machines, or more commonly called FSM. So finite state machine is FSM. And I think you guys have learned about this a bit in 2607, but we're going to talk more about it. So a state machine is defined by a state graph and an X state table. So you have like a state graph here. We have a state table, and in this case, we're going to use a Moore FSM. And a Moore FSM looks like this. It has a bunch of logic over here in green. It has some flip-flops that hold the states. And in this case, if I use 3 flip-flops and I binary encode the states, I would have up to 8 states, right? 2 to the 3 is 8. Oh man, this tool is so crappy. Anyway, there's 8 possible states with 3 bits. And then we have some logic that generates the outputs. And from our state diagram here, we can make a state table. The state table has the current state, A, B, and C. That's the outputs of the flip-flops. It has the next states we're calling A plus, B plus, and C plus. And those depend, there's one input in this case, X. If X is 0, we can see, like if we're in state 0, if X is 0, we stay in state 0. So we stay, if X is 0, we stay. If you're in state 0, you stay in state 0. If X is 1, you go to state 1. And we're assigning the value of state 0 to 0 and the state 1 of 1. If you're in state 1, you either go down, if 0, you go to S2, and if you're 1, you go to S3. So there's S2 and S3. State 3 goes from either to S7 or to S2. It's here and here, and so on. Interesting one to note here is state 7. On the next clock edge, automatically goes to state 0. So state 7, it goes to state 0 no matter what. Doesn't depend on the value of X. And we've given some different outputs here, Z, based on the states. In this case, we said only in state 7 is the Z output 1. All the other states is 0. And we've put a default state in here. And you might notice, I said there's 8 possible states, and we define states 0, 1, 2, 3, and 7. So we used 5 of them. This default covers the other 3 states, right? The other 3 states, no matter what the X value is, if you ended up in those other states, you would go to state 0. We're out of time. Next day, we're going to talk about this default. Somebody already hinted at it. This is super important. This is a number 2 way to get fired from your job. Anyway, on Thursday, we'll talk about that. Any questions before we go?
Yeah, I was just wondering what the number 1 way to get fired from a job is.
The number 1 way is to mess up the reset of your chip. If you mess it up badly, you get a dead chip and you can't do anything. It's the most common way that people mess up their chips. I like to say, well, I'll tell you a story next day. One of my worst nightmares, I had to design a chip for automotive customer and it wouldn't reset sometimes. I didn't design it, but somebody designed it. I spent a year trying to fix it, literally a year nonstop trying to fix a reset problem in the chip. So they can be really, really problematic. Later on, we'll get into resets. I'll explain exactly how it happened, but it's a very common.
Did you fire him?
Well, what it fixed?
Yeah, he did get fired. But we fired a lot of people. I was working at a startup and we fired. I'll tell that story someday too. We fired.
How do you fix it?
Fired more people than we didn't fire. Let's put it that way. Any other questions?